Welcome, everybody. This is your host of the day, Kate Archibald, and super duper stoked to be with everybody today. We're gonna be we got an awesome guest appearance with one of our clients and colleagues. So really excited about that. So I'm gonna hand it off to our presenters today. I'm really excited about this topic. We got an amazing doctor practitioner, Hans Richter. Hans, welcome to the show.
Good
And
morning. Good morning.
so excited to have you on. And Reagan's gonna be diving into some really cool stuff with Hans today. So Reagan, I'm gonna save the butchering of Hans' really solid introduction and hand it off to you.
Hans, let's hear it. So this is an exciting breakthrough that you've had in your practice where you've been using these omegas and you've been telling me about them. And I said, well, let's get you on the show because you can't just tell Reagan. We need to tell the whole world, but let's jump in and I'd love to hear how you discovered these and what kind of clinical results you've been experiencing.
Well, let me share my PowerPoint, right? So fat is the source of life, right? And we've known that for a long time. And basically, these guys are actually really healthy. They eat 20,000 calories a day. And this is their main dish here, chanakonabe. And they actually do intermittent fasting, believe it or not. They don't eat till 11 or 12, and then they jump in 10,000 calories for lunch and then 10,000 for dinner. So basically, we all know our building blocks are amino acids, fats, and carbohydrates. However, fats have been totally ignored, and we need to pay way more attention to that. And there's no such thing as essential carbohydrates. Your body can synthesize all of those yourself. So we've been known not that the pyramid is upside down, right? And humans actually survived on fatty red meats. And there's evidence that we actually made the mammoth extinct. Sure, you've seen that. There's fossils with the spear still in it. So this is where it all went wrong, where we got off the track of fat. And we've seen this studies for the Eskimos a long time ago. And we've been trying to fix our fat problem for a long time. So around the early 1960s, basically, that's when, the food industry got really active, right? And that's when everything really went off the wagon, and the production of vegetable oils and synthetic margarine and so on and so on. But the bottom line is they paid attention to the Eskimos and found, why are they so low in heart disease, right? And interestingly, the Danes that moved over there, they have a much higher incidence of heart disease. So I'm going to talk today about why fat is important, what fats you should eat, what fats you should avoid, and at the end, I'm going to try to sell you something like I learned it from you, and you might find $1,000 less in your wallet. So there is a balanced solution, and we should all get onto that wagon. So basically, one of my central questions is, what is life? And people say, look, it's just the reproduction, your life cycle, metabolism. And you actually have to respond to external stimuli. And pretty soon we'll be talking about the ability to die, but that's another topic. So in my opinion, life is, and I'll get to why this is important, because you're separating the inside from the outside. And that's basically all their life is. As soon as you control the gates, all of the ions and all of the proteins and nutrients going in and out, that's when you actually create life. And the reason I'm showing you this is because we know all the models of how a cell works. And we also know that viruses are alive, right? And that's also what they do. They separate the inside from the outside, namely their DNA and RNA. However, they hijack our system to be alive. But the reason I'm showing you is this because the cell is packed with membranes. We always just talk about this thin little layer on the outside here. The cell actually is a massive conglomerate of membranes over membranes over membranes. So we need to really pay a lot more attention to the fat in those membranes, right? So 50% of those membranes are proteins. If you didn't know that, that's actually quite a lot. And interestingly, when I Googled Gate, Bill Gates came up, but he also is controlling the gates right now. And we know that the membrane is basically not static. It's a fluid model. So 50% of it are proteins, channels, receptors, transporters, all kinds of different functions, okay? So again, this membrane basically keeps everybody happy. And the inside is, in case of a nerve cell, that it's high potassium, the outside is high sodium. So constantly things are being exchanged, and that's what keeps the cell alive. And interestingly, when they first did a freeze fracture of a membrane, you could see the proteins when the membrane splits, leaving holes on the other side. So we do know exactly what the membrane looks like, and this is what it looks like. But nobody has actually seen this because you cannot take a static picture of a membrane. All we know is that the hydrophobic interiors of the lipids, and those are the lipids I'm going to be talking about, are squished together by all of that action from the water and the hydrophilic head groups of the lipids. So the entire interior of the membrane is hydrophobic. There's not a single water molecule inside there. But so here's the trick. The membrane proteins, and I actually solved this structure already in '97, got a Science article from that. The interior of the membrane proteins who span through the membrane are actually interacting with the lipids, and they're packed inside the membrane proteins. And that's also the reason why it's so difficult to get a good picture of those membrane proteins, because they do move around. So membrane are 50% protein, and those proteins do all of the function. And you can kind of see that they will interact with the membranes themselves. So the membrane proteins will change the structure of the actual lipid membrane, and the lipids will change the structure of the proteins. This is very important. Like in this case here, when the channels open, the membrane actually stretches out. When the membrane thins out, it actually also opens the channel. So there's a lot of actioning happening, and I'll get to the point where that is relevant. So again, a membrane only sits in the membrane, a membrane protein only sits in there because it's hydrophobic. So it's excluded from the water, and it interacts on the surface of the membrane with the first hydrophilic amino acid. So in this case, lysine, which you can see all the nice bonds to the water here. Okay, the other 50% now are lipids. And there are three types of lipids. There are saturated fats, unsaturated fats, and cholesterol. And 60% of that fat content is unsaturated. And we have all kinds of different lipids. And it turns out there are 1,000 different species of lipids. And each of those membranes that you basically have in your cell have different compositions of these lipids. Most of them are phosphatidylcholine, but you can see how this composition changes, like here between the plasma membrane and between the mitochondria. However, what this doesn't tell you is actually how much unsaturated fatty acid is really in those lipids. And there's very little information actually about that, what is going on with those lipids. And, the main lipids we always pay attention to are the PEs, which are 45% of your lipids, and they actually contain very little polyunsaturated acids. and they're mostly present in your nervous tissue. And we also know the PC, which is your egg yolk, and those have massive amounts of unsaturated. And they always have two chains. One is unsaturated, one is saturated. But really, there's very, very little information about how much unsaturated fatty acids are actually incorporated in those lipids. And basically, the other lipids here, they have functions. So for example, if they're prevalent, they're triggering apoptosis or cell signaling. So again, the lipids matter because they change the shape of your cell. So in order to get a budding event, when you divide up a cell, you need to have a negative curvature, a positive curvature, and a flat curvature. And all of those are facilitated by different lipids. And these lipids here, for example, in this case, you can see like one side of the membrane has a lot of unsaturated DHA, and the other one is saturated, and that will cause this curvature. So extremely important, right? But could it possibly mean that this picture that we're always talking about, making the membrane fluid, is just a fantasy? So there's new evidence actually showing that the omega-3s actually don't really pay that much attention. So in this case, they did this study where the entropy changes with the addition of more unsaturated fatty acids is actually very, very little. And we're starting to really question everything that we know about lipids, and I'm going to get to that point too. So 1978 already, they found that if you artificially change the composition of the membrane from 63, like I mentioned, 60% of the 50% fat is unsaturated, down to 35%, we're basically getting severe inhibition of cell growth. So that's the budding event that I was talking to earlier. If you don't have unsaturated fatty acids, you cannot divide your cell. And this obviously is very interesting in the context of cancer and in the suppression of tumors and the induction of the differentiation of the cancer cells and the apoptosis of the cancer cells. So let's get to medicine. And medicine, we try to keep things simple. And simple means we focus on a few things that we can measure, and that is your omega-6 to 3 ratio. And we've known this for a long, long time. There are thousands and thousands of studies showing how your omega-6 to 3 ratio is basically linked to all disease. And we've known for a long time that you need to keep that ratio as low as possible, and that excessive amounts of omega-6 are inflammatory, but I will get to that. And we know that our Western diets are full of omega-6s and low on 3s, and that's basically suppressing or increasing inflammation in our bodies. So this is an interesting picture I just came across from a talk last week. This is the interior of your artery, right? And it's also packed with lipids that actually expose sugar. And could it be that, you know, we're paying attention to a completely wrong idea here, that it's not about the cholesterol? So the omega what, you all know this, it doesn't matter how long the chain is, the fatty acid chain, you just count from the end, and that's what makes the omega-3. So it's in the 3rd position, no matter how long this is in the 6th position, then you count from there. So that's all you basically know that, you know, the omegas are basically more flexible, and here's a nice picture of that. So these are all, there's a lot of omega-6 fatty acids, but we only really pay attention to 1 or 2 of them, which is the linoleic acid and the DGLA. And they're extremely important in regulating inflammation, but we really only pay attention to very, very few of them, and arachidonic acid, I'll get to that too. So all of these other fatty acids, they need a lot of studying.
Hey everybody, Reagan Archibald here with Go Wellness. And if you liked this episode, if it actually helped inspire you to be a better practitioner, help more people, establish a much better foundation for your business, then I'm going to ask a favor of you. And that favor is for you to share this with somebody you care about and love in the healthcare field. I don't mind if it's an acupuncturist, a functional medicine practitioner of any sorts, a naturopathic doctor, a medical doctor, any type of endocrinologist or specialist. We need to get this community strong, and we can't do it without your help. So I want to thank you from the bottom of my heart for all the hard work you're putting in and day out. I know it can be a grind, especially with some of the chronic cases that you're treating, but this show will help transform the way that you think, help transform the way you practice, and change the lives of thousands. Thank you for being part of our community.